Hello, everyone. We are looking at complex number today. It is a topic from our phase 3, and we are looking at exercise 1 today, question number 1. We start with that. And complex number, as we know, is an important topic. We'll see questions which involve other topics as well. So, exercise 1 is usually the simpler one. So, let's see question 1. So, find all non-zero complex numbers satisfying this equation. We know that in a complex number, if what we see as one equation is actually two equations. We can equate the real part and imaginary part from both sides of equality. So the process to start always is, let us say that z is equal to a plus ib. That is a complex number which has a as a real part and b as the imaginary part. I'm taking the same which has been taken in solution. And now conjugate, we can just write conjugate is a minus ib, and z square is a square minus b square minus 2aib. So now we can put all the values here. So a minus ib is equal to I into z square. So I into a square minus b square. And if I put I again here, then it becomes 2ab. Now all you have to do is equate the real part from here and imaginary part from here. Now, one thing we can see right off here is that if I equate the real part, then a is equal to 2ab. So this is actually a quadratic equation that will give me two values of a or b. Similarly here, minus b is equal to a square minus b square. So again a quadratic, it will give me two values. So we can start from either place. We can get two values of a or b here and then use it to find the other two. So the same thing has been done here, we can see. So just solve this, we get two values and then use this value a is equal to 0 in the second equation and get the other two values of b. So similarly, we put then next b is equal to minus half here and then get the other two values of a. So in all, we get four combinations of a and b, that is four complex numbers we are going to get. Okay, so that's how we approach such question. Thank you.